So today we should discuss about sets. What is a set? A set is a well-defined collection of objects. For example, if I say we have set is denoted by this capital letter A, which is having the elements 1, 2, 3, 4. And in this set 1, 2, 3, 4, they are just finite elements. In the same way, I can denote a set with the names. For example, the set B, which is having Raju, Shivam, Ravi, etc. Raju, Shivam and Ravi. So this is the set B, which is containing a well-defined collection of exactly 3 objects, and these 3 objects are the names. In the same way, we can have a set, for example C, which is containing some characters A, B, C. We can have a set D, which is a combination of some characters as well as some numbers, right? So these are the 4 sets, and these 4 sets are well-defined collection of objects, and these well-defined collection of objects does not necessarily mean that they should be ordered. These objects can be unordered at the same time. So next definition is a null set. Next definition is a null set. Null set is generally denoted by phi, right? So what is a null set? It is a set which is containing no elements. If I am saying it is a set which is containing no elements. It is a set which is containing no elements. If I denote a null set like this, we denote a null set like this, or we also denote a null set like this. But if we denote a null set like this, then what does it mean? It means it is a set which is containing one more set, and that set is a null set, right? You can say it is a set which is containing a null set, right? So that means when I'm saying this, which is set which is containing null set, then it is not equivalent to phi, because phi itself is denoting null set. Okay, now next is, what is a power set? What is a power set? For example, we have a set A which is containing the elements 1, 2, 3. Then what is a power set of A? Power set of A is a set which is a set of all the subsets of the set A. For example, what are the set of all the subsets? The first set can be phi. Phi is a subset of A. In the same way, we can have a set with single element. We can have a set with 2 elements. We can have a set with this 1, 2, 3. We can have a set which is containing 1, 2. We can have a set which is containing 1, 3. We can have a set which is containing 2, 3. At the same time, we can have a set which is containing 1, 2, 3. Right? So what is a power set? It is the set of all the subsets. It is the set of all the subsets. Now, if I am saying subset, then what is a subset? If I define what is a subset. For example, if there is a set A which is containing 1, 2, 3, 4, then if there is a set B which is containing the elements 1, 2, then I can say that B is a subset of A. I can say that B is a subset of A. So these are very basic definitions. Let me define it again. If I am saying we have a power set, then we can say if any subset of A which is not a trivial, if we have a subset means if every element of A is also an element of a set B, then A is called a subset of B, right? For example, again here in this case, if every element of B is also an element of A, then you can say B is a subset of A. What I am saying is, if every element of the set B is also an element of set A, then we can say that B is a subset of A. But here in this case, you can see we are not putting any kind of restriction on A. That means the set A can contain more than these elements, right? It can contain the element 3, it can contain the element 4. In the same way, if I can say there's a set C which is containing 1, 2, 3, 4. In this case, then every element which C is containing, all those elements are also a part of the set A. So 1 is also there in A, 2 is also there in A, 3 is also there in A, and 4 is also there in A. So we can say C is a subset of A. At the same time, in this special case, A is also a subset of C. A is also a subset of C. Now if I say we have a set D which is containing the elements 1, 2, 3, 5. Here I cannot say that D is a subset of A. Why? Because the set D is containing an element 5 which is not present in the set A. So we cannot say that D is a subset of A. At the same time, we cannot say that A is a subset of D. Why? Because the set A is containing an element 4 which is not present in D. Therefore, A is not a subset of D. Right? So these are very basic definitions. Now here you can see in the case of power set, I said that power set is the set of all subset of a particular set. The set of all subsets of a particular set. In this case, you can see we have a set phi. Phi is a set of all the it is a subset of all the sets. We have this set which is containing only one single element 1. So this one element is also present here, therefore it is a subset. This 2 is also present here, therefore it is a subset. This 3 is also present here, therefore it is a subset. If there are 1, 2, then 1, 2 is also present here, therefore it is a subset. 1, 3, 1, 3 both are present here, therefore it is a subset. 2, 3 both are present here, therefore 2, 3 is a subset. 1, 2, 3 all are present there, therefore it is a subset. Now if I can say the cardinality of a set A, if I say the cardinality of a set A, cardinality means the number of elements. If the cardinality of the set A is n, then the cardinality of the power set of A will be 2 raised to power n. What is the cardinality? Cardinality means what are the number of elements. If I am saying the set A is containing 3 elements, then the power set of A is going to contain 2 raised to power 3, that means 8 elements. So how many elements are there? This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, and this is 8. Therefore the power set of A is going to contain 2 raised to power 3, that is equal to 8 elements. Okay, I think this is very simple and trivial definition. Now the next definition which we are going to study here is the definition of a proper subset. So proper subset is generally denoted like this, and a subset is generally denoted like this. So what is a proper subset? A subset which is not equivalent to that particular set. For example, if I am saying A is a set which is containing 1, 2, 3, 4. This is a set B which is containing 1, 2. In this case, B is a subset of A. At the same time, B is a proper subset of A. But if I am saying there is a set C which is containing 1, 2, 3, 4. Now this set C is a subset of A. It is a subset of A. At the same time, C is not a proper subset of A. So what is a proper subset? So any subset A which is not a trivial subset, of that subset, then it is called as a proper subset. Okay, fine. So these are some basic definitions. Now let us look at some more definitions related to this set theory.